Welcome to my YouTube channel. We are going to do quiz number 4 today, and it will consist of questions from NET, NAV, REX, Tech. This will boost your performance. This will boost your performance and preparation for airline exams, as it contains mixed questions from different topics, like airline questions are. So let's start with question number 1 for today. At an aerodrome tower, red and green beacon light indicates that it is a civil aerodrome. Red and white light indicates it's a civil aerodrome. White and green light indicates that it is a civil aerodrome. Very important question. So civil aerodromes are identified by white and green beacon. Water airport, white, yellow. Heliport, white, yellow, green. Military airport, 2 whites, 1 green. So the correct option will be option C. White and green beacon light indicates a civil aerodrome. In class Bravo airspace, very important. IFR and VFR flights are permitted, yes. All flights are subjected to ATC control and are separated from each other, yes. So option C is the correct option. So both IFR, VFR flights are permitted, but VFR flights must obtain specific clearance before entering class Bravo airspace. Okay, without obtaining that clearance, you cannot enter class Bravo airspace. Next, question 3. Which weather phenomenon signals beginning of mature stage of a thunderstorm? So very important, in a cumulus stage, thunderstorm has 3 stages of its life cycle. First stage is cumulus stage or the starting stage, incipient stage. It is predominated by updrafts, the air currents rising in the atmosphere. In the mature stage, you have updrafts and downdrafts. The downdrafts are accompanied by precipitation. Next is the dissipating stage or the end stage, the end of the life cycle of thunderstorm, and it is marked by the downdrafts. Okay, it is marked by downdrafts, and the thunderstorm will start fading. Okay, so these are the 3 stages of a thunderstorm: cumulus, mature, and dissipating. So beginning of the mature stage of the thunderstorm. So mature stage is indicated by the start of rain. Okay, by the start of rain. Next, hazardous wind shear is commonly encountered where? So hazardous wind shear near warm or stationary frontal activity. So near warm or stationary fronts, you do have wind shear, but they are not hazardous in nature. So option A is wrong. When the wind velocity is stronger than 35 knots. So just having a wind speed of more than 35 knots doesn't make it a wind shear. So option Bravo is also wrong. In areas of temperature inversion and thunderstorms. So that is right. So in areas of temperature inversion and thunderstorm, you have hazardous wind shears. So you have to be careful. Question 5. If the main gear retracts athwart ships and the nose gear retracts forward, what will happen to the position of CG? Now this is your, let's say, this is your aircraft. Okay, this is your aircraft. Now the main landing gear of this aircraft, which are this, after taking off, this landing gear will go inside the fuselage, in the belly of aircraft. So they will go, both will start retracting sideways in the fuselage. Okay, not outwards but inwards in the fuselage. Okay, whereas the nose gear will be retracted either forward in the fuselage, or in some cases nose gear retracts backward in the fuselage. Okay, so now they have asked us that main gear retracts athwart ships and the nose gear retracts forward. What will happen to CG? Now when the main gear retracts athward ships, means the right gear will be retracted inward, the left gear will be retracted inward. So overall both of them will cancel out each other. So center of gravity will not be influenced by this. The center of gravity will be influenced by the position and the movement of the nose gear. If it moves forward, the CG will move forward. If the nose gear is retracted backward, the CG will move backward. So I will show you one video. In that you see how the main landing gear of that aircraft retracts in the belly and the nose gear retracts ahead. So you will see that. Here you can see the main gear retracting inside, nose gear retracting forward. Okay, so I will show it again. The main gear retracts in the belly, the nose gear retracts forward. So this is how the landing gear retraction happens, and the answer is if the gear retraction happens in the forward ahead or forward direction, the CG will move forward along with it. So gear retraction will not affect CG, that is wrong. Gear extension will not affect CG, that is also wrong. Gear retraction will move the CG up. Gear retraction will move the CG forward. Now in the question it's mentioned retracts forward. So answer will be CG will also move forward along with it. Okay. So very important question. Next, question 6. A radio wave with a horizontal magnetic component would be best received by what kind of aerial? So now a radio wave is made up of two components, electric and horizontal. If the electric wave, if the magnetic, correction, electric component and magnetic component. So if the electric wave is vertical and magnetic wave is horizontal, we call this vertically polarized wave. Vertically polarized wave. Okay. If the electric field is horizontal and magnetic field is vertical, it will be called a horizontally polarized wave. So it depends on the orientation of the electric component. If electric is vertical, we will have vertical polarized wave. If electric is horizontal, we will have horizontally polarized wave. Remember that. Okay. So now in this case, we have a magnetic component which is inclined horizontally. If magnetic is horizontal, that means electric will be vertical, and therefore this wave will be called electrically polarized wave. An electrically polarized wave will be received by an aerial which is vertical. This is vertically polarized. Okay. So if electric is vertical, so aerial that will receive it will also be vertical. So answer is option A. Question 7. The following radio navigation symbol belongs to what radio instrument? Radio ground station. So this symbol is for your VOR. Is for your VOR. Remember all the symbols. So as you begin your flying IFR and you will be using charts. So in that you will come across these symbols many times. So VOR, this is your VOR symbol, Vortex, VOR DME. Next, ILS is subject to false glide paths. So what happens is, this is your glide slope transmitter. You have 90 hertz, you have 90 hertz lobe and 150 hertz lobe. Okay. Now the 150 hertz lobe is near the ground, and this is your 3-degree glide slope along which your aircraft will descend, right? Along which your aircraft will descend. So what will happen? This is the 3-degree glide slope, the common area, the overlapping area between 90 hertz and 150 hertz signal. That is where the correct glide slope lies. But due to the reflection of the or the interference of the ground with this 150 hertz lobe signal, additional or false lobes will be generated, but these lobes will be above the 3-degree glide slope, above the 3-degree glide slopes. Okay, so that is due to the ground interference or ground reflection. So correct option will be spurious signals reflected by obstacles, multiple lobes in the vertical plane, backscattering of antennas, ground returns. So this is the correct answer. ILS is subject to false glide paths resulting from ground returns. So with this, we come to the end of this lecture. I hope you have understood all the 8 questions. You were able to answer majority of the questions out of these, and you have learned something new today. So keep learning. All the best. If you have liked this video, hit the like button, subscribe to this channel if you haven't, and share this video with all your friends and colleagues. Thank you for your time.